Okay. Who do we have? Who do we have? Okay. Okay. So Michael left, right? Okay.
I did.
All right. So let's dive in. Let's dive in. So today we'll be looking at non-EVM chains. I have 20 slides here, but since we are not coding, it shouldn't take time to round everything up. So yeah, my name is Nosi Febo, and I'll be taking you through non-EVM blockchains, non-EVM chains today. This is week 10 of the Web3 class. Like we have come a long way, and I think we'll have just like 4 weeks more to go, and we'll be done. So yeah, let's dive in. Let's dive in. So just before I start, if you have any question, please don't hesitate to ask. And I'm going to be asking some questions. So please try and answer the questions I am going to be asking. Alright, so yeah. So first of all, we are going to talk about non-EVM chains, but actually we need to know what EVM chains are. So the Ethereum virtual machine is called the EVM, right? And EVM chains are blockchains that use the EVM as the virtual environment to run smart contracts. So there are blockchains that use the EVM as virtual environment to run smart contracts. Popular examples are Ethereum, BNB Smart Chain, Phantom, and Arbitrum. Think about it like this, right? Think about it. Think about it like this. Your program, something like your browser, for instance. Think about your browser like as a smart contract. Like this is just a scenario. Think of your browser or of your browser as a smart contract. Now, what does your browser run on? It runs on the operating system of your device, which can be your laptop or your mobile device. Right, that is what it runs on. Now, for the smart contracts, if it's running on an EVM, if it's running on a blockchain like Ethereum, it runs on the execution environment for that smart contract. It's called the EVM, the Ethereum virtual machine. Did you guys get that logic? You guys get that scenario? Right, so the smart contract runs on the EVM just the same way your browser runs on your operating system that is on your laptop. Sure, you get? You guys get that whole scenario?
Yes.
Okay. So that's what it is basically.
Yeah.
That's what it is basically, and we have Ethereum, we have BNB Smart Chain, we have Phantom, and we have Arbitrum. So these chains right here make use of the Ethereum virtual machine, right? To run their smart contracts. Now let's look at some non-EVM chains. So what are non-EVM chains? Non-EVM chains are blockchains that don't use the Ethereum virtual machine to run their smart contracts. It's as simple as that. Like there's no two ways about it. EVM chains use the Ethereum virtual machine to run their programs, that is their smart contracts. But non-EVM chains don't use the Ethereum virtual machine. That means if, for instance, now like currently I'm using a Mac to run my browser, right? So if for that means if someone else, it's just like saying someone else now is using a Linux operating system to run his browser, while me I'm using my Mac to run my browser, right? So obviously we are using completely different environments to run the same thing. So that's exactly what we're saying here. For the EVM chain, they use the Ethereum virtual machine, which you can say is an operating system. While for the non-EVM chains they don't use the Ethereum virtual machine, which is like saying someone is running his browser on an OS that is not Mac OS, that is not Macintosh, that is not Mac OS, right? So it can be any other OS like Linux, Windows, or any other OS, right? So yeah, so that's basically it. Examples are Near, Flow, and Solana. We're having a look at these three, including Avalanche. We're having a look at Near, Flow, and Solana today, and we also have a look at Avalanche. So apart from these three that are here, and apart from Avalanche, like, can you guys mention any other non-EVM chains, like any other chains that don't use the EVM to run their smart contracts?
I know of Libra. That one is the one by Facebook.
Okay. I need like, okay, I need like four to balance it. I've already given four. So let's get four. Let's get four. Okay, you have mentioned Libra, so that's one. Any other one?
We have SUI, SUI.
Yes, exactly. WAV Sui. WAV Sui, that's true. WAV Sui. There are many now.
And funny thing is that there are many actually.
Yeah. What were you about to say, Blessing?
I wanted to say that when people think about
Sorry,
Binance.
my network ran out. I don't know. I missed something.
Okay. Now
Okay.
say so we should repeat the question.
Okay. So I was saying the chains, right? We have for non-EVM chains, we have near flow. So sorry, Osama, I'm coming. Sorry.
Okay.
So for non-EVM chains, we have near flow and Solana, and we also have Avalanche, right? So I'm like, tell me more non-EVM chains. I've already given you 4, so give me 4. And Blessing mentioned Libra, so I want you guys to give me 3 more. Okay, Blessing also mentioned Sui.
Cardano.
Yeah. Cardano is 1. Blessing mentioned Sui, so we have 3. I need 1 more.
Third chain.
What did you say?
Third chain.
Thorchain.
THOR.
TH. Oh, Thorchain.
That is the one that has room. Yes.
Yeah.
It is.
I have to be honest.
I
I know Thorchain, but I've not dived like deep into it. I know it's related to Ethereum. I think it's related to scaling Ethereum, kind of, but I've not dived
Yes.
deep into it. So yeah, I know there's Thorchain. I know there's Thorchain too. So Thorchain doesn't use an EVM, right? It doesn't use the EVM or any implementation of it.
No, doesn't.
Okay, so yeah, so those are chains. I was expecting you guys to mention chains like Aptos, Sui. Let's mention Sui. Actually, I was expecting you guys to mention Sui because like they are like everybody, they are kind of hot. And I was also expecting Kanto, but yeah, you guys mentioned all that chains. It's fine. So let's
They're
move
dashing
on.
money right now. So
Yeah. Those are the new ones now. So let's move on. Let's start with Nier. So we're going to be moving on to the Nier blockchain. So Nier, right? What is Nier blockchain? The Nier blockchain is a smart contract platform that uses parallel sharding storage and computation technology to scale. That's what it is basically. Then the Nier blockchain uses Rust and assembly scripts to build smart contracts, right? So developers that build on the Nier blockchain will use Rust and assembly scripts, right? So we'll come back to sharding, but for now we just know that the Nier blockchain is a smart contract platform like Ethereum, and uses parallel sharding storage and computation technology to scale. So when you're talking about when you are talking about Solidity for Ethereum, right? You use Solidity to write smart contracts in Ethereum. For Nier now, they use Rust and assembly scripts, right? That's what they use. But this assembly script right here is the same thing. Is to WebAssembly the same way TypeScript is to JavaScript. Do you guys get that? Or should I come again?
Yes.
Okay. So exactly. So assembly script gives assembly script help to add types to WebAssembly, right? So that's basically it for Nier. And Nier also I remember they released an SDK that helps you build programs on Nier blockchain using JavaScript. Yes, they released an SDK for that. I think that was last year actually. I know I had a look at it. So I think that was last year. Although the SDK, as at the time I checked, does not let you build financial applications to JavaScript. So you can only build non-financial applications. So that's it about Nier. So let's have a look at sharding. What is sharding? What's sharding? So sharding is the process of segmenting a blockchain's network nodes into different groups called shards, right? It separates it's just like you have 100 nodes, then you separate like, okay, these 25 nodes will be on a particular group, 25 nodes will be on another group, like that. So you have 4 groups of nodes, and they will have like 25 nodes, 4 groups of nodes, and they will have like 25 in each group. So each of those groups is called a shard. So yeah, something like that. So that's just a simple explanation of what sharding is. So a shard is a set of nodes that can execute and validate transactions without communicating with nodes in other shards. So that's basically what it is. Just think about it like this. Normally on the Ethereum blockchain, right?
like different pods in a container.
Yeah, exactly.
Yes.
Yeah. That's what it is basically. That's what it is basically. So it's an approach to scaling, right? It's an approach to scaling. So the way it helps scale is like this. We have, let's say we have if you look at the Ethereum blockchain or even the Bitcoin blockchain, for instance, when you send a transaction to the Ethereum or the Bitcoin blockchain, your transaction is processed and validated by all the nodes on the Ethereum network. That is, immediately they get your transaction, they'll first process it and validate it to see that it is correct, right? They'll first process it and validate it to see that it is correct. So it is processed by all the nodes in the Ethereum network. So that alone, right? If let's say all the nodes are processing, all the nodes have to process your transaction to be sure that it's correct. Like, let's say we have 100 nodes, that means your transaction has to be processed by all the 100 nodes, right? Before we are sure that okay, it is correct. So imagine the amount of time it might take. But let's say for instance now, we now divide the network into different groups called shards, and we now say okay, your transaction is going to be sent to a particular group, and what has to happen is that if that group agrees on that your transaction is valid, it is valid. And if they execute your transaction and they decide that it is valid, they don't need to communicate with the other group to know if it is valid or not. So what now happens is that if, for instance, now I sent 4 transactions, right? My 4 transactions can go into the 4 shards, and they will validate and they will execute and validate my 4 transactions at the same time. Sure, you get, they'll execute it and validate it at the same time, right? And let's say it takes 1 second to validate and execute my transactions. It will just take 1 second on that particular blockchain, because the 4 transactions went to different shards in that same network. That is the different groups in that same network. So all of them will validate my 4 transactions in 1 second. So that you can just say in 1 second I'm done with my transaction. But if you are comparing it to the way most blockchains are currently, if it's 100 validators or 100 miners on the same network, my 4 transactions will have to go to all the miners, and they will have to validate everything one by one sequentially. So if one transaction takes 1 second, it now means that my 4 transactions will take 4 seconds to process. But in a sharded network, it will take 1 second to process all my 4 transactions. Do you guys get that scenario? Hello.
Hello, yes, I can hear you.
Okay. Okay. Did you guys get the scenario I just explained?
Not
Can you come again?
Oh,
Yeah.
okay. So I was actually talking about sharding, and I was saying that sharding is an approach to scaling, and that's what NEAR currently uses. That is the NEAR blockchain. So I mentioned that currently in the Ethereum network or even on the Bitcoin network, all the nodes on the network have to, if you send a transaction, let's say you send a transaction, all the nodes on the network have to process your transaction to be sure that it is correct. You guys get that part, right? All the nodes on the network have to process your transaction. You guys get that part?
Yeah.
So let's say if we have 100 nodes, nodes on the network, the 100 nodes have to process your transaction. This is just a scenario, right? The 100 nodes have to process your transaction to be sure that it is correct. But if for instance now we decide that okay, before we shard the network, right, before we divide the network into groups, let's say for instance now, if you send 4 transactions, and let's say one transaction that you send takes 1 second, it means that it takes 4 seconds to completely execute and validate all your transactions, right? Can you guys hear me?
Yes.
All right.
Yeah, we can.
So since it will take 4 seconds to execute and validate your transactions, that's how Ethereum and Bitcoin currently work. Right now, if we now think about sharding, we say that sharding is like dividing those 100 nodes on the blockchain network into different groups. So let's say I divide the 100 nodes into 4 groups. So those 4 groups will now have 25 nodes in each of them. I now decide that okay, my transaction, I'm going to send these 4 transactions to each group. Right? I'm going to send it to each group. Now each group can decide to execute and validate my transaction on their own and they'll be sure it is correct without communicating with another group. You get? So if I now send 4 transactions to each of these 4 groups, it means that all the groups will execute and validate all my 4 transactions at the same time. Meaning that if I send 4 transactions in, I'm sure that by the end of 1 second, my 4 transactions would have been processed, because these groups will process everything in parallel. Meaning they will do everything at the same time, and you don't need to communicate with each other to check it whether on that transaction that whether the other transaction that the other group is running is correct. You guys get that scenario?
Yes.
Yes.
I do.
All right.
Well, I just have a bit of questions for the security part. Like,
Yeah. Of course.
my question is just
Okay. Continue.
but are all the transactions going to be verified by all the group of the nodes?
No.
Or is it that a particular node is just going to verify the transaction? Why it's only, or is it that they will all verify the transaction?
Okay. So different blockchains will have different implementations. They can just decide that. Some can decide that it can be like a proof of stake. It can be like a sharded proof of stake network, for instance. They can say that in each shard, right, one blockchain, one node in each shard is the one that will execute it and validate it, while the others will just have to verify that the transaction is correct. That is, while the others on that same shard will have to verify that the transaction is correct. Do you get that?
Okay.
Yeah.
Yes.
So that is what can happen. But there are different implementations of sharding. There was a time Ethereum wanted to do this kind of sharding, but right now they are taking a different approach called dank sharding, right? So there are different implementations. So for the near blockchain, I don't know the specifics of their own implementation, but one thing we need to know is that they actually do it in shards, right? They do it in shards, and
So I lost you.
Oh, you lost me at what point? At what point did you lose me? At what point did you lose me? Hello, can
Can
you
you
hear
guys
me?
hear me?
Yeah, I can hear you, Blessing. I don't know if others can hear me. Can you hear me, Blessing? Hello, can you guys hear me? Can you guys see my screen and hear me?
Yes. We can hear you. I'm hearing you.
Okay.
I can hear you.
Okay. Let me go back. Where is it? Okay, where is the slide? Okay, yeah, this is it. Okay, so that's what I was saying, right? So there are different security compromise that you make with sharding, right? So there is this issue of fork choice, right? There's this issue of fork choice because actually all the shards still have to agree on the main block that they will be adding their own transactions to and all that. So there are different issues like that, but Near takes their own an approach of, let's say, if when all the shards are done with processing their transactions, they can put their transactions in their own blocks, and it will gather all those blocks and create a central blockchain for all of them, that kind of thing. So that's what Near does, but there are different implementations for sharding, right? But that's what Near does. So it's just like this now. You have one shard here, right? So a set of nodes will process this a set of nodes will be running this block, and it's on that set of nodes will be running this block, right? And they don't have to communicate, but there's a possibility of actually running cross shard transactions. So you get, like, they don't necessarily have to communicate, but someone can do a transaction that will require one shard communicating to a different shard, right? So Near has that capability of doing cross shard transactions. So this sharding brings about the possibility of running transactions in parallel, so which like makes it easy for blockchains to scale, right? Yeah. So that's it about sharding. So let's move on. Let's dive deeper into Near. So comparison with Ethereum, like how is Near different from Ethereum, or how is it similar with Ethereum? So for the Near blockchain, they use POS, proof of stake consensus algorithm, and Ethereum actually uses sorry, what consensus algorithm does Ethereum use? I'm just curious if you guys know, because it's a simple answer, but I just want to know.
What's the question again?
What consensus algorithm does Ethereum use?
Proof of stake.
Proof of stake, right? Yeah, it's proof of stake. So they both use. I already mentioned it here. Oh, I actually wrote both. I wrote both. I actually thought I wrote near uses proof of. I thought I wrote near uses proof of stake algorithm, consensus algorithm. Yeah, I didn't know I wrote they both use proof of stake consensus algorithm. So gas fees are calculated algorithmically. Oh. As per EIP 1559. So on here, gas fees are calculated algorithmically. On Ethereum, gas fees are also calculated algorithmically, right? That is the base fee for the gas fee on Ethereum is also calculated algorithmically. So it uses Ethereum uses a simple algorithm where we say, okay, the base fee will increase or decrease based on block usage, right? Based on network usage, right? It increase or decrease based on network usage. And here also has their own implementation where the gas fees are calculated algorithmically, right? So, but this statement is supposed to say that as per EIP 1559 in Ethereum, because I don't think NIA uses EIP 1559. It's an Ethereum implementation, right? So yeah. So, but they both calculate their gas fees algorithmically. Does anybody have a question?
Sorry, please, can you mute your mic? Thank you.
Okay. So, no question for this point, right? Okay.
No, my own question, I wanted to first go through all the different EVM before I say my opinion. It's more of a statement I've noticed.
Okay. So, NIA uses Rust and assembly scripts to build smart contracts. We already mentioned that. Then NIA has easy account identification built into its protocol, e.g. non-custodian.nia. Right. So I actually have this account, and I'm going to show you guys this account now. Let me show you. So Ethereum has ENS, right? Ethereum has ENS, and we have what do you call it?
Yeah.
And we have you can have an ENS name like nonce.eth, vitalik.eth, sasal.eth. So it shall ends with .eth. The same thing with NIA. NIA has .NIA on its own here. Where is it? Oh, sorry. I don't know if I can enter the, what do you call it? Okay, yes, here. Yes. So nonce.nia, right? Nonce.nia is what .nia is what NIA uses. But the difference between Ethereum and NIA now is that this whole stuff right here, right, is embedded in the protocol. That is, you can send a transaction that you can interact directly with the protocol and tell the protocol that you are sending a transaction to nonce.nia, and it will understand. But if you are interacting with Ethereum and you say you are sending a transaction to, let's say, nonce.eth, the protocol won't understand what you are saying. Like the Ethereum protocol won't understand what you are saying, because the Ethereum, the ENS names are built as applications on top of Ethereum. They are not embedded in the Ethereum protocol. Do you guys understand that? So Ethereum will only understand that. Will only understand if you are saying, okay, send a transaction to this address. It doesn't understand ENS names, but it understands addresses. But with NIA understands these names that end with .NIA, and these kind of accounts are called named accounts. The other accounts, like this one here, which has an address. So this address here, for instance, is called implicit accounts. They are called implicit accounts, but this other one are called named accounts on NIA. So if I come to the NIA Explorer now, you see it says account at nonce.nia, right? That's the account. This NIA Explorer understands that this is the account, right? You understand that this is the account, and so I can use it directly as an address anywhere, and the NIA protocol will understand it. unlike the Ethereum protocol. So do you guys get that whole logic? Hello.
I understand.
Okay. Let's move on. So yeah, so that's the about near. So developers can upgrade their smart contracts on the near blockchain, but it can be disabled permanently. Like on Ethereum, you can also upgrade your smart contract actually. But the thing is that with Ethereum, the way we currently upgrade smart contracts on Ethereum was not a function that was built into the Ethereum protocol. It was not a function that was built into the Ethereum protocol, but with NEAR, it's a function that is built inside, like as part of the protocol, like as part of the way the NEAR blockchain operates. Like with NEAR, it's known and it's a fact that you can upgrade your smart contracts, and you can also set it such that it can no longer be upgradable, just for people to trust more in your contract and to know that it's a trustless mechanism, so that like maybe you will put them by upgrading your smart contract code and taking all their money, that kind of thing. So you also have the option of disabling upgradability on your smart contracts. But for Ethereum currently, like if you notice something, once you deploy a smart contract in Ethereum, you are not supposed to be able to remove your smart contract code. But there's a way they go around that whole situation and use different mechanisms to bring about upgradability in Ethereum. You understand? Do you guys get what I'm saying? But the Ethereum protocol on its own does not allow you to modify code that is stored in a smart contract. Do you guys get that?
Yeah.
So that's it about NEAR and Ethereum. So let's go on to, I think it's Flow next. Yeah, Flow. So the Flow blockchain. What is the Flow blockchain? The Flow blockchain is also a smart contract platform that uses the multi-row architecture to scale without sharding. So it doesn't use sharding, unlike NEAR. If you remember, NEAR uses sharding, and we talked at length about what sharding is. But Flow blockchain does not use sharding. This is a multi-row architecture. So I'm going to talk about this multi-row architecture. But you guys know CryptoKitties. Do you guys know CryptoKitties?
Yes.
Okay.
Yeah.
Okay. So CryptoKitties, in case you don't know CryptoKitties, you should know CryptoKitties. If you don't know CryptoKitties, tell me. Like, mention it here in the chat. Maybe you are too shy to say you don't know CryptoKitties.
No, I don't know.
You don't know what CryptoKitties are? For real?
No.
Wow.
I'm new to the world of Web3.
Oh. So CryptoKitties, I'm coming. So CryptoKitties are an NFT. They are an NFT. They are they were the first popular NFTs on Ethereum. The first popular collectibles on Ethereum. Like among all collectibles, they were the first popular ones, and they were the ones that I think as of 2017, their trading volume caused the Ethereum protocol to experience it wasn't a lag per se, but it made it difficult to use the Ethereum protocol because of the number of transactions that were happening. Right, it made like gas fees were too high because of the number of transactions that were happening, and all those transactions involved selling and buying and also breeding CryptoKitties at that time. You get what I'm saying? So CryptoKitties were the first popular NFTs on Ethereum, but they were not the first NFTs, but they were the first popular NFTs, and they were created by Dapper Labs, right? So this Flow blockchain now is also created by Dapper Labs, which also created CryptoKitties. So Flow has popular apps like NBA Top Shots. Have you heard of NBA Top Shots?
No.
Top Shots. You've not heard of NBA Top Shots too? Okay, so NBA Top Shots is also an NFT platform that allows you to sell moments. They call them moments. NBA, like the main basketball competition that they do in America now. So this NBA Top Shots allows you to buy and sell moments. So moments are like I think they are mostly pictures. So let's say someone is playing a basketball game and is at the point of scoring is at the verge of scoring a point. When they dunk now, all those kind of stuff, will snap them in the air, and all those pictures that they take, they can come on NBA Top Shots and sell them as moments. So these NBA Top Shots here actually have a partnership with the official NBA, and like a lot of people have been using it. There was even a time I tried buying a moment. I don't think I bought one finally do, but I know I checked out the platform. Yeah, so NBA Top Shots is quite popular. I think it was very popular in 2021. Yeah, it was really, really popular in 2021. Even Flow Blockchain there was a recent NFT collection called Barbie that was launched on I don't know, sorry, it wasn't called Barbie, but I think it was from the creators of Barbie, right? It was launched on the Flow blockchain, and the Flow blockchain is what I'm about to talk about is in this part. So the Flow blockchain has some interesting characteristics, including multi-role architecture, which we already mentioned here, right? Multi-role architecture. And it's also a resource oriented the other characteristic is that it is a resource oriented programming. It will use a resource oriented programming language. So it also allows upgradable smart contracts, and has consumer friendly onboarding, right? It has consumer friendly onboarding. That's why people were able to, normal regular everyday users were able to use NBA Top Shots, because the Flow blockchain is geared towards making the use of they are geared towards making their platform consumer friendly, so that people can easily get onboarded and use their platforms, and they have easy fiat arms. You know what fiat arms are, right? Hello, can you guys hear me?
Yeah, we can hear you now.
Okay, yeah. So I said they have easy fiat arms. So that's mostly it about Flow. And then moving forward, let's see what this multi-role architecture is all about. So the multi-role architecture, you see this video, right? I took it from YouTube. Actually, it was from a channel. It was from one of Flow's channels. So we're coming back to this video, but let's look at what this text says. So Flow scales by having special rules that nodes on the network can decide to participate in. So this allows nodes with a particular role to focus on being very good at that role, so they can specialize in doing specific things on the network. So there are 4 rules in total. There is the collection, consensus, execution, and verification rules. Now think about, let's move from known to the unknown. Now think about the Ethereum blockchain. Nodes, if you have a node on the Ethereum blockchain, right? If you have a node on the Ethereum blockchain, you are doing everything from collecting transactions, verifying the transaction, executing the transactions, right? Verifying the execution, and also making it available for other people that might need it, right? Making it available for other clients that might want to communicate with you to get your the transactions that you currently have, or making it available for dApps in order for them to access data that you currently have. That's the way the Ethereum blockchain, Ethereum nodes on the Ethereum blockchain work. They perform all the rules that involve creating a block, right? They perform all the rules that involve creating a block and executing transactions. Each node performs all the rules. But with the Flow blockchain now, the approach to scaling is a multi-role approach, where all these rules, like getting the transactions, executing the transactions, verifying the transactions, and making it available, right? And making it available for dApps and other clients, right? All these rules are separated such that a node on the network can decide that it's just this rule I'm going to work on, and it's going to specialize on making itself very, very good for just that rule alone. So so that means it can work faster, right? It can work faster. So apart from that's not what I mentioned now is not the main attribute that make the multi-role architecture good. But let's talk about what really makes it good. There is this stuff called assembly line. You know, assembly line is when we're making cars, right? You guys are familiar with assembly lines when you're making cars?
Not really, but you can continue.
Okay. So assembly lines. Let me just explain what the assembly lines are. So if you've watched all these videos where they are talking about car manufacturing, where they are showing a car manufacturing plant, for instance, you notice that there's something like a belt where it's not necessarily a belt, but there can be a line of workers where the first worker here, let's say he fixes the headlight on the car, then the next worker paints it, then the next worker does the interior, then the next worker does something else. So things like that, right? That's the way so just like that, that's the way the assembly line works. So it means that at every point in time, each person is working on a different car. So let's say for instance now we want to do 3 cars, right? It does everybody does not have to, like, one person does not have to sit down and make sure that he builds the car from start to finish. We can all be working on the 4 cars at the same time. So immediately this person is done working on something for the car, moves it to the next stage, and I begin working on the other car. So it means that we are working in parallel, right, on the 4 cars at the same time, right? So we don't have to wait to all work on one car and then work on the next car and then work on the next car, right? So our each of our rules is being used at the same time in making sure that we can work on those 4 cars, right? So so that's the way the assembly line works. Do you guys get that short explanation?
Yeah.
Okay.
Yeah, I do. Thank you.
So that's the assembly line. So think about, so for the Flow blockchain now, they call it pipelining. So think about this. These 4 rules that I mentioned. This first rule here, collection, is the one that makes sure that the data on the Flow blockchain is available for dApps like NBA Top Shots. That's what they do. So the consensus rule here now is the one that makes sure that they can come in agreement on the state of the blockchain, right? Then there's the execution rule, which obviously executes your transactions. That is, it runs your transactions, right? Then there's the verification rule. So maybe execution is done, it moves to verification. So verification checks that, okay, this transaction that has been run by the executors, is it correct? So what happens now is that it takes a form of an assembly line. So let's come to this video here. Let me restart it. So if you watch now, the blocks are coming in from collection. They first go to consensus, then to execution, then they move to the verification stage, and they finally come back to consensus. And after they come back to consensus, the consensus now agrees that, okay, the consensus group now agrees that, okay, this is what everybody has done, and I'm going to decide if it's what we want or not. Then after that, it's added to the main blockchain right here. So this means that if you notice something, you notice that at every stage of this process, each rule actually has a block that it is working on. So what I'm saying is that when the block leaves collection and comes to consensus, let's say the first block now is block 1. Let's say this collection comes to consensus, and let's say this collection the collection guys and comes to the consensus guys. What happens is, if this is block 1 and block 1 comes here, this collection starts working on block 2. This collection rule starts working on block 2. The consensus rule moves the block that they got here to the execution rule. Right? They move it to the execution rule, and then at the execution rule, right? At the execution rule, they start working on block 1, and the consensus now gets block 2 from collection, and collection start working on block 3, right? So in parallel, they are working on multiple blocks in parallel. So they don't have to wait for a particular block to be mined or to be they don't have to wait for a particular block to be mined or to be proposed by the network first. They all work on the blocks at the same time, which makes everything work faster. So let's say I want to produce, let's say it takes 4 seconds, let's say 10 seconds to produce one, let's say it takes 10 seconds to produce one block. So it will take 10 seconds for block 1 to get from here to being in the main chain, right? Let's say it takes 10 seconds. Now, and let's also say that it takes like 3 seconds. Is it with 3 seconds be fine? Okay, let's say it takes 2 seconds for a block to move from one stage to the next stage. So let's say we start from block 1 now. If block 1 to start here and go through this full process, it takes 10 seconds. But note that immediately block 1 leaves here and comes in here, block 2 comes here, meaning that after block 1 is done, it will only take and we say that it takes 2 seconds for a block to move from a particular row to another row. So it means that it will only take 2 more seconds before we get block 2, as opposed to the first 10 seconds that we had to wait for block 1. So it just goes on like that. At the first stage, block 1 comes in after 10 seconds, then block 2 comes in after 2 seconds, block 3 comes in after 2 seconds, block 4 comes in after 2 seconds, and like that, just because each rule is working on a block at the same time, and they don't all have to work on one block at the same time. If they all have to work on one block at the same time, it means that they will all have to wait for 10 seconds to produce a block, and then after the 10 seconds they'll start a new block again. You get? But because they're all working on different blocks at the same time, they can keep on producing blocks every 2 seconds. Do you guys get that whole stuff? You get the analogy I use here? If you have any questions, please ask.
It's a round robin system. Sorry, my network was crappy. I don't know. I had to just subscribe on another line.
Okay.
I missed some part of it, just like I'll watch the video, but I think I understand what you're trying to explain.
Alright. Yeah. Round robin. Will I apply round robin here now? I don't think round robin quite. Okay. Can you tell me why you mentioned round robin?
Like, okay, the reason why I said that is it allocates a particular time to every block. So, but what I don't get is if the waits for the block to be completed before passing it on, where you have another block coming in. You said a block comes in at every 2 seconds.
Yeah, that was a scenario though. I was just making an example. I'm not saying
okay.
I'm not saying that is the standard that Flow uses. I was just talking about a scenario, right?
Okay.
But yeah. I think you understand what I was saying. So time has gone. Actually, I thought I was going to be faster though. So let's be fast for our 8th slide now. Sorry if I'm kind of going to be fast now. So on that we also mentioned that the Flow blockchain has this stuff called resource-oriented programming. I think I mentioned it here. Resource-oriented programming. So the Flow blockchain has something called resource-oriented programming. If you're in our 2 class yesterday, we talked about object-oriented programming. That's on that paradigm of programming, right? Which we are very, very familiar with in the Web2 world. So with Web3 now, they brought about resource-oriented programming, and so the Flow blockchain developers use Cadence, right, which is a resource-oriented programming language, and they used to build smart contracts on Flow. So the resource-oriented programming refers to a new way of defining ownership, which allows crypto assets to have their ownership defined in the programming language. Now, if you look at the right here, there is a keyword here, resource. This is just an example. So this is Cadence actually. This is Cadence, and it's looking almost like Solidity though, but it's Cadence. So this is resource. This is the keyword resource, and it is applied to a kitty collection. And this is also resource which applied to a CryptoKitty. So when you put resource on each of these variables here, it helps the programming language to understand that this is a particular it helps the programming language to understand that this it's quite an object. It helps the programming language to understand that this entity right here is a resource, and the programming language now understands that okay, this resource now has rules that apply to it. Right, it has rules that apply to it before it can be updated, before it can be deleted, before it can be before it can be updated, and before it can be deleted, right, and before it can even be created, right. So it means that this stuff you have to define rules for all that kind of stuff. And on one particular stuff about the about this resource-oriented programming now that Flow uses is that if you are familiar with ERC 721 tokens, that is NFTs, you know that if you have an ERC 721 smart contract, it stores the state, meaning it stores a mapping of an address to the tokens that address has. You guys get that? That is the contract, the state of who owns what, that is which address owns what, is stored in the smart contract. You understand that, right?
Yes.
Yeah. So it means that you have an address. So it means that you have your own address, and for you to get the CryptoKitty you own, for instance, you have to call, you have to communicate with that smart contract for that smart contract to tell you the crypto kitty you have. But when we're now talking about the resource oriented programming approach now, that particular entity that your contract, that your address has, is going to be stored in your account directly. You get, it's going to be stored in your account directly, so it allows the programming language to know that, okay, immediately I see an entity that has a resource that has so a resource. I don't know if I'll call it a modifier now. I don't know if it's known as a modifier in Cadence, but I think it looks like a modifier. So it made the programming language to understand that anything that has a resource modifier attached has specific rules before it can be touched, and any transaction that is trying to update that particular entity has to follow those rules. So if you look at it here now, this kitty collection resource has rules. It has functions for withdraw and deposit and all that kind of stuff, right? It's different from what we're familiar with in Solidity, right? So yeah, so that's mostly it about the resource oriented programming. That's mostly it about the resource oriented programming. So yeah, so let me move forward. So more flow properties. We have upgradable smart contracts, and they're also consumer friendly. Sorry. So unlike Ethereum, smart contracts on Flow are upgradable. The developers can add an indication to show that the contract is still upgradable, and then remove the upgradability capability. Wait, this does not sound right. But they can remove the ability for them to be able to upgrade it later, this to achieve stability, right? So, but it's just like NIE. We also mentioned with NIE that smart contracts are upgradable on NIE. The protocol understands that smart contracts are upgradable. The same thing with Flow. So they are trying to achieve a developer-friendly ecosystem that allows smart contracts to be upgradable, right? And yeah, so that's the about upgradable smart contracts on Flow. Like I earlier mentioned, smart contracts on Ethereum are also upgradable, but it's just that the protocol is not defining the protocol that, okay, smart contracts can be upgradable. We just have mechanisms that go around that non-upgradability of state in the Ethereum blockchain. So yeah, it's also consumer friendly. I actually set up a Flow wallet today, and it was very easy. Like, what happened? Sorry, I didn't even need to store a seed phrase. Where is that wallet? Okay, I think I can get the wallet here. Where is that wallet? Okay, block2swap. Yes. So this block2swap actually helps me get a wallet. What happened was that I just had to like enter my email, and they automatically gave me a wallet. Although I don't know how secure it is. Right, I don't know how secure it is, but it was quite easy for me to get started. Immediately I got the wallet, I just had to transfer money from Binance into the wallet. Or they sent a 6-digit code. But yeah, I can use my email to sign into the wallet. That's what I'm trying to say. Right? Although I don't know how secure it is. So they are like you earlier mentioned, Flow blockchain aims at being consumer friendly. Right? It aims at being consumer friendly. So yeah, so that's about Flow properties. So moving on, comparison with Ethereum, it uses a proof of stake consensus algorithm like Ethereum. Flow was explicitly designed to support games and consumer applications that require high scalability to operate. So it's like this also kind of talks about the consumer friendly approach that the consumer friendly initiative. Do I call it an initiative now? The consumer friendly they are just focused, consumer friendly focus, right? That the Flow blockchain is taking, right? This boils down to that. Now the other thing is the execution nodes on Flow have high staking and hardware requirements. Like we earlier mentioned, Flow uses a multi-row architecture for their nodes. So what they are saying now is that the execution nodes here have a high staking and hardware they have high staking and hardware requirements, meaning they are usually for you to have an execution node, you usually have to operate it in something like a data center, right? So they have these high requirements, so you can't operate it somewhere like, although you can operate it in Nigeria, but where I am right now, I don't, because some people say that they're able to operate nodes in Nigeria right here. I don't know how they do it with our light situation, but yeah. So for this kind of node now, you actually need high. You have to have high staking and hardware requirement. The high staking means that you have to commit a large amount of money. You have to stake a large amount of money before you can become an execution node on the Flow blockchain. And the high hardware requirement means that you need like, let's say, state of the art infrastructure, infrastructure in order for you to process and execute transactions fast. So that is mostly it about the Flow blockchain. Although there are other cool things about the Flow blockchain. I think one cool thing I saw was this, my wallet. Where is that wallet? Oh yeah, this I can show you the stuff. Okay, let's see. I don't know if it can show me recent, but if I come to let's see, Flow Explorer. Okay, yeah, I know I opened this Flow Explorer today. Their addresses are short. Like, if you know, with Ethereum addresses are 20 bytes, meaning they have 40 hex characters. But with Flow, their addresses are short. Let me show you an address on Flow. So this is an address on Flow. This is an account. This is the address. It's short. It's far shorter than Ethereum. I don't know. That's what I noticed about it, but I don't know if it's also aimed at being consumer friendly with these short addresses. But yeah, we have that. So that's it about Flow. Is there any question about Flow before we move on to Avalanche?
No questions for me.
Okay. I need one more person to say no more questions. So before I continue. Oh, I need one person to ask a question.
No more question.
Okay. Okay, you didn't let me
Sorry.
finish.
Okay. Before we move to Avalanche, let me just mention something. So in my research of non-EVMs, I've realized that not everybody's all about like solidity, but I've realized like solidity and Rust is more, let me use the word, friendly to other languages. Apart from the fact that you can use it to build apps on its own, I see more blockchains adopting Rust. Like you said, even Flow, even looking at Libra, and like now even Starknet and L2. The language is Cairo, but very similar to Rust. So I'm just like, what do you think about that?
Okay, well, see, let me confess to you. You know, I actually started working on these slides yesterday, and I was supposed to finish it. I thought I was going to finish it yesterday, but I slept off. Today I actually planned to start learning Rust. Today I was supposed to learn Rust as at 2 p.m. today. I think I was supposed to do it like from 2 to 4 today, but I wasn't able to do it because I was still working on the slides. So yes, if I'm not able to start Rust today, I'm going to start learning Rust tomorrow, regardless of me already knowing Solidity, because I actually have been seeing the way Rust is like, it's becoming, let's say, ubiquitous in this space. Solana uses it, Cairo uses it, and different programming language that are being used on different blockchains have either their a variant of Rust or something, just like Cairo, right? So yeah, so Rust is really becoming ubiquitous in this space, and I think it's really, really useful. Actually, I did plan to only start using Rust, only start learning Rust. I also plan to start learning Golang today. I plan on doing each of them for like 2 hours at least for a start. So yeah, Golang and Rust. Although I have touched Golang before, but I've not touched Rust at all, and I think it's really, really good. I feel like I'm going to be like a superhero when I'm done with Rust and all that kind of stuff. So yeah, I think you should learn Rust too, but you should actually start with something that is easy and fast for you to use before you start talking about, okay, let me go into higher level, because I think they mostly said Rust is intimidating. It's really, really, it's intimidating for new developers, right? That's what you've said. Although that's what I've heard. That's not my personal opinion. I guess when I start, you can ask me next time I'm presenting if what I now think about Rust, and I'll be able to give you a coherent, like a good answer, right? So yeah, I think you should learn Rust if you're already good with other programming languages. But based on what I've heard, I don't think you should start with Rust. Right? Yeah, you should start with Solidity or start with JavaScript, just to be good with, just to understand how blockchains work. Then when you start Rust, you learn the Rust programming language and you need to apply it in other fields, right? So things like that. So does that answer your question?
Yes, it does. Thank you.
Okay. Yeah. So that's about Rust. Rust and other stuff. Yeah. And don't forget, we also mentioned as Rust. Okay. Yeah. Yeah. What's up?
You said something about Golang.
Is
there a blockchain that makes use of Golang as a language?
Yeah. Whether there's a blockchain that makes use of Golang as a language, I don't know for a fact if there's a blockchain that, okay, it depends, right? I know that Golang is used to build clients that run blockchain protocols. So what I'm trying to say now is there's even between the blockchain protocol and smart contracts. So the blockchain protocol is what enables smart contracts to run. It's like saying the blockchain protocol now it's almost like I can say it's the EVM. It's the blockchain protocol. Let's think about it like this. The Ethereum protocol has the EVM as a part of it, right? It has the EVM as a part of it, right? So something like that. So it's not like saying, okay, the OS that you have, what was used in building the OS, right? What was used in building the OS. So that it's the same thing as saying, okay, the OS, you can compare the OS of a computer to the clients of the blockchain. You can compare the OS to the blockchain protocol, right? But the smart contracts that run on the blockchain protocol, right, you can compare it to your programs like your browser and other stuff. You know, the language that was used in writing your OS is different from the language that will be used in writing. It's most probably going to be different from the language that is going to be used in writing your browser, right? So your OS can be built in something like it can be built in Rust or C++ or whatever, and your browser cannot be built in can be built using JavaScript. So you get there's this, I've forgotten the JavaScript implementation that is used in building desktop apps. I think it starts with E. Whether it was, I forgot the name. I think it was. Let me know. Say a name that.
Electron.
Yeah, it's Electron. Yeah, Electron. So you can use Electron in building desktop app, the desktop application, but the actual OS will be built using C++. So what I'm trying to say now is that Golang can be used in writing blockchain protocols, but I've not seen any blockchain that uses it, right? That uses it to build smart contracts. So for the Ethereum blockchain now, for instance, they use Golang in building Get. Get is an implementation of the Ethereum protocol. So they use Golang building Get, but to write smart contracts on Ethereum, you use Solidity. Do you get that? So that's where the difference comes in. Hello, did you get it? If it's not understandable to you, I can break it down. Just ask. Just say. Yeah. Hello.
Sorry, can I say something? Yeah. So like now, one thing I've noticed in the game is I always want to get into blockchain engineering.
Mm-hmm.
Everybody knows about the DApp, the development, that's Solidity.
Mm-hmm.
But now the protocol itself, that means like building something like Ethereum, it's not that popular.
Yeah.
And like now, I feel like for a more long-term career strategy, is it not best to focus on learning like protocol languages?
For a long-term career strategy, I don't think so. Maybe you might have your opinions about that, but I don't see a reason why, because I personally think you can just learn multiple languages for writing smart contracts on different blockchains, right, and still be very good at it. Do you get that?
Yeah, I get that, but now looking at the example, please can you turn off your mic? Okay, sorry, not meant for him to go out. So now looking at example, when you look at roles that when you look at all those crypto job roles, you then see that yes, the basic of it all will not be okay, Solidity developer. But now they look for things like, okay, protocol engineer or blockchain integration engineer, and those things are not the basics of just any language. Like now, I just went into these aptos that we're talking about, and I looked at the role, trying to just go back to where it was. Okay, I'm looking at just careers.
Okay.
And now looking at them,
if you can drop the link, let's see it.
Okay. Let me just drop the link.
Oh, I'm going to Avalanche already. I'm going to Avalanche it.
So you can check it out here. There you see things like software engineer, blockchain core. And you see things like software engineer, networking. Just one aspect. You see things like example, storage. And when you go and look at what the role, like now the one of, when you now look at the role, the language itself, you now see that they'll be asking you for things like example, this Move blockchain, they ask for knowledge of Rust or Move itself, and Move is the programming language.
Yeah.
Itself. And Solidity is like the least.
Where is Move there? Where is Move here? Sorry. Which one Move. Are they asking for Move?
I am under programming languages. The one I actually checked out was their developer relations role.
Okay.
And that was the one I checked out. I checked out developer relations engineer, and the requirements there for you is that you should have knowledge of Rust, Move, and TypeScript. That's for developer relations.
Yeah, I'm developer relations now. So let me see. Rust. Okay.
So if you're asking that of a dev role, now what about an engineer?
Okay. But you should actually know where you are applying. I think these Aptos labs now, these are the guys that are actually building the protocol. So I don't expect them to be looking for. Move for Aptos. Move is the language for writing smart contracts on Aptos. So this is Aptos Labs, and they are the ones building Move and maintaining the protocol. So I don't.
Can you check out blockchain core? That one there, you see they're asking for Rust, Go, Swift, or C++.
Which one?
Like all that blockchain core, software engineer, blockchain core.
Software engineer, programming language.
Because we have under cryptography that one.
Very top.
Yeah, I've seen it. Okay, so where is it?
You see,
okay, yeah, this one.
What we are looking
Rust,
for.
Go, Swift, or C/C++. Is it not this one?
Yeah, this one.
Yeah, this one, Abby. And yeah, now it's still boiled. Okay. Let's talk about this. Sorry about the noise. Let's talk about this. What is your exact question?
But now looking at your Web3, there is that.
Sorry. Can you come again? Seems
can you hear me now?
Yeah, I can hear you now.
Okay, so I was looking at like example when you're coming as a development, that's Solidity and other like languages, and now this protocol engineering. It's not best for if you're going to be a developer for a long time, like at least 10 years. I know you should have different kinds of skill, but for example, when you see things like Rust, Golang, those things are like code. It's not just the basic Solidity that you just think you need to know, and that is all.
Yeah, definitely. You shouldn't just know Solidity. Just knowing Solidity alone won't really be an edge. But although there are other edges like knowing Solidity and knowing how Solidity actually works deeply, like how you know how Solidity works to the core, right? And things like that. You can have an edge with that. But yeah, just knowing Solidity will not be fine. So yes, if you actually if you actually want to be able to switch, you want to be able to switch between careers between different blockchains easily, you should know this kind of Rust, Go, C, or C++, right? If you want to switch careers easily. And I think if you want to switch careers easily between different blockchains, because I think most programming languages that are actually coming out now, that are used in building smart contracts on different blockchains, actually sometimes a derivation of all these, right? They're actually sometimes a derivation of all these. And if you know all these, it's easy for you to diving into the protocol itself and know exactly what they are doing and stuff like that. So yeah, if you want to move across different blockchains, it's nice you know this. But if you just want to build apps and you just want to focus on building dApps, you don't want to focus on building protocols, I really don't see anything wrong if you just focus on knowing just Solidity, right? But it's not just knowing Solidity, you have to like know Solidity really well, so you have a higher chance of getting a job or something than other persons. And I can't say for the next 10 years, but it looks like when the EVM, because if you look at it currently now, the EVM is propagate, like it's becoming, I would say it's becoming ubiquitous now, but it's propagating, right? There are a lot of blockchains that are now using the EVM, and it's the same thing. If you know Solidity, you can move across those blockchains easily. So it means you can code on Binance Smart Chain, you can code on Chronos, you can code on Ethereum, you can code on Arbitrum, you can code on Optimism, right? You can even code on Avalanche, that is the seed chain on Avalanche, right? You can code on Phantom. There are a lot of them, right? So yeah, with the proliferation of the EVM, you can also move across different blockchains. So I just think you need to focus on what you actually want. What do you want? Do you want to build protocols? Do you want to dive into the meat of everything? Do you want to dive into the engine and see what and know how everything works underneath for blockchains? Or you want to just be at the top building dApps and interacting with consumers and all? So I actually think like if you know Solidity, you should be good to go. But if you want to actually be able to move across different blockchains and be able to dive into the meat of how they actually function, low level programming languages like this are fine. But like I also mentioned, if you understand Solidity and the EVM, as the EVM is proliferating around now, you can still move across different blockchains as a dApp developer and all that. So I still think it's based on personal preference at the end of the day. I can't say that in the next 10 years Solidity won't be there, because currently Solidity is going everywhere because of the EVM, right? So yeah, that's my perspective though. People might have other perspectives. Yeah. So
thank you. I have a question for you.
Okay.
So you what is your own choice?
My own choice.
Actually, you want to stick to just that?
Wait, what was this last part of your question?
Do you want to stick to that development, or you want to move into protocol? Like, what's your own?
I personally, if I see anywhere belay face now, but actually, I will actually prefer doing dApps, because I feel at the end of the day, if you want to actually make money, it's still going to be being a dApp developer, because it's just like which example now? It's like Facebook. Facebook does not have an OS, right? But they have an application that runs almost in all OSs, that kind of thing. And most applications like Spotify, even your Chrome browser, say Google on their own, they are all applications now. Most of them are applications. Although we still have people that we still have companies like Windows and Mac OS that are actually in the weeds building the whole OSs, right? But most of what we actually see are the applications, right? It's mostly the applications that we actually see and use, right? So yeah, I will actually prefer being a dApp developer, but I don't see anything wrong if I go into core stuff. I would like to go into core stuff just to be a badass kind of person, just to become better in programming. But at the end of the day, I want to settle as a dApp developer just to like make money. Yeah, right. So yeah, that's for me. Let's move on.
Thank you.
Time has gone. So yes, so that's Flow and Ethereum. So let's move to Avalanche. What's the time? 7:24. Okay. So Avalanche. What's the Avalanche blockchain? Avalanche is actually an ecosystem of blockchains. It provides an open source platform for building dApps and enterprise software. Each blockchain is on something called a subnet. So Avalanche is not a blockchain. So sorry if I was this. I always said I was going to remove this. I don't know why I didn't remove it. So Avalanche is not a blockchain. You should know that first. So what Avalanche is that it's an ecosystem of blockchains. Like it's a group of blockchains, right? It's a group of blockchains. So they provide a platform for you to be able to build blockchains, right? And each blockchain is run on something called a subnet. That is a subnetwork, right? A subnetwork. That's what it is. So we're going to go into subnets. But anytime you hear Avalanche, what you are mostly, anytime someone says go and do this on Avalanche, right? Go and do this on Avalanche or whatever. What they most probably will be saying is that you should go and do it on the Avalanche C chain. That is the Avalanche contract chain. We'll talk about the Avalanche contract chain, which is just one of the chains in this ecosystem of blockchains, right? So this thing is moving faster than the shadow. I've not moved yet. Wait. So yes, let's go to subnets now. So subnets. So what is subnet? So on Avalanche, subnets are a set of validators that help a blockchain. Like I already said, Avalanche is an ecosystem of blockchains, like a group of blockchains. So subnets is a set of validators. That is a set of nodes on that help a blockchain on the Avalanche ecosystem achieve consensus. So they help a blockchain basically they help a blockchain produce blocks. That is what they do. A set of nodes that help a blockchain on the Avalanche ecosystem produce blocks are subnets. They are called subnetworks. Now a subnet can validate for more than one blockchain. So a subnet can validate for more than one blockchain on the Avalanche ecosystem. A validator, that is a node that is in a subnet, can also be part of many subnets. Then there are also private subnets. So then before we go into that private subnet, let's take a look at this diagram. If you see this diagram, we have the primary network. The primary network is in Avalanche. There are some chains that the Avalanche ecosystem has already created. Those are the primary network, and the Avalanche chain is a part of that primary network. Now on your own, you are free to go and create a sub network. Now for each sub network, if you look at it, this is subnet 1. So subnet 1, you just try and ignore these lines for now. So subnet 1 right here has how many validators? 1, 2, sorry, I was clicking it. So subnet 1 has 1, 2, 3, 4. It has 4 validators on their network, on the network. So this subnet now is supporting a particular blockchain. They are helping to provide consensus for a blockchain. In other words, they are helping to produce blocks for a blockchain, right? So that is what this subnet is doing. Now a subnet can validate for more than one blockchain, right? So basically this primary network, I already mentioned that the primary network is made up of some 3 chains that Avalanche has already created, and which are the C chains. Now the primary network is supported by all the subnets. They are supported by all the subnets on the Avalanche ecosystem. So it means that this subnet 1 is validating for a particular chain, right? It's validating for a particular chain on the Avalanche ecosystem, and it's also helping to achieve consensus for the primary network. You get that? So it's able to achieve consensus for the primary network and also another chain that that it also supports, right? So this subnet 1 helps to achieve consensus for a network, and also helps to achieve consensus for the primary network. So this primary network now is supported by all the subnets here, but only subnet 1 helps to achieve consensus for a particular network. Same goes for subnet 2 and same goes for subnet 3. So if you come here for instance, where is this Avalanche link? Okay, so this is Avalanche and this is the primary network. The primary network is made up of the Avalanche C chain, Avalanche P chain, Avalanche X chain, and these were created by the Avalanche developers. So we also have subnets. This is a subnet on that subnet on that subnet. These are different blockchains. Everything here, these 3 are different blockchains. These 3 are different blockchains. But this is the primary network, and as I mentioned, this blockchain here, right here, we have its own subnet, right? And the subnet will be supporting this particular blockchain. They will also be helping to achieve consensus for this particular blockchain, right? That is, they will be able to produce blocks for this particular blockchain. But they will also be able to produce blocks for this primary network. That is, the subnet of this one will produce blocks for. We also have to produce blocks for this one. The subnet for this one also have to produce blocks for this one. and the subnet of this one will also have to produce blocks for this one, but the subnet will only that group of validators that in that subnet, we only have to produce blocks for this one and this one, not the rest of them here. Sure, you get. Now these two subnets can share validators. That is, a validator can be on this subnet and can also be on this subnet, right? So something like that. Validator can be here and it can also be here. And sorry, I made a mistake. Actually, subnets can achieve consensus for more than one blockchains. Actually, they can achieve consensus for more than one blockchain. So that's it. This is the full list of the subnets right here. This is the primary one, and these are the other ones. So I think it's almost like Cosmos. Like, Cosmos is actually an ecosystem of blockchains too, if you're familiar with Cosmos. So yeah, and that's Avalanche. This is Avalanche. It's an ecosystem of different blockchains. So moving on, here is this stuff here. So that's for Avalanche. And yeah, the C chain, like we earlier mentioned, the C chain is the contract chain and is one of the blockchains on the Avalanche ecosystem. We saw the C chain just now. It runs on the EVM and allows smart contracts to deploy on the EVM to be compatible with Avalanche. Right, you can port your smart contracts that are deployed on Ethereum to Avalanche easily. This allows Ethereum's contracts to be easily portable to Avalanche, like I just mentioned. So it means that you can actually use MetaMask with Avalanche C chain. Right, you can use MetaMask with Avalanche C chain. So if you are aware, you can use MetaMask with EVM, any chain that runs EVM. If you are looking for any network, just a quick aside, if you are looking for networks that run EVM, or you want to add a network to your MetaMask, you can come to chainlist.org right here. So chainlist.org has a list of all the chains that run EVM. So I can connect my MetaMask wallet and add a network. So what I did was I came here, searched for Avalanche. So this is Avalanche actually. Connect my wallet. Okay, trying to connect to the Avalanche chain. Alright, so but basically you can connect your wallet and add any network here. You can add Polygon, Optimism, Chronos, Phantom, Avalanche, Arbitrum, anyone. So yeah, they are all EVM chains right here, and this is one of the blockchains on the Avalanche ecosystem. This is just one of the blockchains. So but it's the main chain that people usually use. So let's get back to the slides. Yeah, so that is it about Avalanche. Let's look at the comparison with Ethereum. So comparison with Ethereum. So Avalanche uses a proof of stake consensus protocol. That's all the chains we are talking about use proof of stake consensus protocol. Now the development of the C chain and the Ethereum are pretty much the exact same thing. This sentence is not complete, sorry. But developing on Avalanche C chain and developing on Ethereum are the same thing. You use the same tools, hard, Foundry, Truffle, or whatever. And yeah, you just use what you use in building on the Avalanche C chain. You also use it building on the Ethereum chain. So if you have questions, just hold your questions. The time is fast spent, so you ask your questions at the end. So just get ready. We just hold your questions for now. So the Avalanche token is hard capped, unlike Ethereum, which has no hard cap. So Avalanche uses AVAX token and it is hard capped. I saw the number yesterday. I think it was 720 billion or 720. I think it was 720 billion. That is the cap for Avalanche. And if you have the Avalanche memory pool is not public. If you are familiar with Ethereum, you know the Ethereum has something called mempool. That is the memory pool. That is where your transaction is kept until it is mined in a block. So the Avalanche memory pool is not public, unlike Ethereum. That of Ethereum is public. And if just a quick aside, the mempool is one of the reasons why we have MEV, and that is maximum extractable value and other stuff. It's not necessary, but I just wanted to mention that. Yeah, so Solana, who has not heard of Solana? Okay, sorry, who has heard of Solana?
Yeah, I have.
No, I thought you guys were going to say you have not heard of Solana now. Because I know the normal question if I had asked who had not heard of Solana now, nobody will say they had not heard of Solana. Okay, so Solana, what is Solana blockchain? The Solana blockchain is under proof of stake blockchain. I already mentioned all of them are proof of stake that uses the Solana virtual machine. So unlike the EVM, uses the Solana virtual machine, which uses it to run transactions in parallel. So if you know something about Ethereum, Ethereum does not run transactions in parallel. That means that if you send 10 transactions, each node on the network will run transaction 1 before they run transaction 2, before they run transaction 3, and so on. But for Solana, it's possible to run transaction 1 and transaction 2 at the same time. That is in parallel, so it will be faster to run all the transactions. So the major difference between Solana and other blockchains is its use of proof of history as a clock. We'll talk about proof of history. I think that's the next thing we're talking about. So proof of history. So what is proof of history? Solana's proof of history allows it to keep track of time. If you are familiar with Ethereum, you know there's this thing called timestamp. They attach it to each blockchain. If you have also worked with Solidity, you know that you can access the block. There's this global variable called block.timestamp. Can anybody say hi if you know? Don't say hi, say you know it. If you know it, just say you know it.
I know it.
Okay, so yeah, so you can access timestamps in Ethereum. So unlike so for Solana, unlike Ethereum, it doesn't use timestamps. So what it uses is the proof of history, or it uses proof of history hashes. So Solana proof of history allows it to keep track of time, unlike timestamps in Ethereum. Unlike other blockchains like Ethereum that use the timestamp, yes, Solana uses a hash which contains data to prove that time has passed. Right, it uses to prove that time has passed, unlike Ethereum that uses timestamps. Now the input for the hash is a recent block hash and a set of transactions that arrived after that transaction. So what's happening now is that in order for me to prove to, let's say I'm a node on the Solana network and Blessing is on that node, in order for me to prove to Blessing that time has passed, and to also prove that I want to prove that time has passed, and I also want to prove that a set of transactions came in after a certain time. I'll use a hash basically. So I'm going to hash a previous block hash. I'm going to take a previous block hash, and I'm going to take a hash of some transactions that came in after that block, right? And I'm going to hash everything, and I'm going to produce the next hash. Now I'm going to send this hash to Blessing, and she's going to be able to verify that these transactions here, these transactions that have this transaction IDs came in after this previous hash, which was the hash of the block hash of the last block, right? So yeah, so that's what is happening here. Now there are also some other approaches that Solana takes to be sure that these transaction IDs here are actually arrived after this hash, right? But this is just the general way of doing it. And this is actually a calculation for the block hash of Solana. Just as a quick aside, Solana does not have blocks, right? Solana does not have blocks, but yeah, this is just an equivalent of a block hash. So we're almost done. Yes, comparing with Ethereum, Solana. Actually, there was a time I built something on Solana, and I didn't even know what I was doing, to be honest. But it was a dApp. I was not building any smart contract. I was not using Rust or anything. It was a dApp that was interacting with a smart contract. Someone has already done something. I was just looking at what the person did and not replicating it, but I was using it to understand what I was meant to do for my own. And to be honest, everything looked really, it almost looked like it was really confusing, something like that, right? Because it's far different from Ethereum. So yeah, Solana uses the SVM while Ethereum uses the EVM. We already mentioned it. Now smart contracts of Solana are called on-chain program. So you know that a smart contract basically is a program that exists on the Ethereum blockchain. It's just a piece of code that exists on the Ethereum blockchain. There's nothing to it. Forget the smart that is on it. It's basically a piece of code that exists on the Ethereum blockchain. They are not smart. They just thought of a cool name to give them. That's why they call them smart contracts. So yeah, it's just a piece of code that exists on the Ethereum blockchain. So Solana does call them on-chain programs. That's what it calls them. It doesn't call them smart contracts. Although everybody calls them smart contracts though. Now, unlike Ethereum where smart contracts store data, on-chain programs do not store data. They only store their code. Smart contracts, if you are familiar with the way if you are familiar with the global state of Ethereum, you know that each account is able to store it has a separate storage from its code, right? It store its code and it also store its state, right? So something like the CryptoKitties that we earlier mentioned, it stores a mapping of the amount of tokens each address has. That state is stored in that smart contract. But for Solana, the smart contracts, that is the on-chain programs, don't store state. Their state is actually stored. They don't store data. They are stateless basically. It's stored in a different account that the smart contracts own, and those smart contracts they're actually marked as executable, right? So things like that. So data for the on-chain program are stored in a separate account that they own, and accounts on Solana pay rent to the Solana network for state maintenance. You know, on Ethereum we don't pay rent, we just deploy and just keep on deploying and deploying. But for Solana, you have to pay, each smart contract actually has to pay rent. You have to pay for being on the network. Always, I think you'll be purged, and if you don't have to be purged, you better pay up. So that's mostly it. And I think we're done. Yes. So conclusion: despite the proliferation of the EVM across alternate layer ones and layer twos on Ethereum, there are still blockchains that use alternate virtual machines out there. Yes, EVM is proliferating everywhere, but there are still blockchains that use other virtual machines to run their smart contracts. Now, the list of blockchains we have looked at isn't exhaustive. Now, there are other blockchains that use, like you earlier mentioned, some. So there are other blockchains that use other virtual machines apart from EVM, but it covers some of the, this slide covers some of the major ones. So that's it. Thank you for listening. I presented this, and you can follow us on Twitter at blockchain.au, and this is our mail. So questions, anybody has a question? I'm expecting a lot of questions. Yeah.
Okay.
Yeah. Any question? I can share the slides in case you want me to. I can go back in case you want me to go back to somewhere that seems confusing. So I will have a look at it. We still have some time for questions.
I think basically most of the questions that Blessing asked actually fits into most of the questions I wanted to ask. Understanding that basically to move across the blockchains, you need to, I think it's not, understanding solidity too is good, but once you're moving outside EVMs, enabled chains, you also have to learn some other programming languages.
Yeah.
And I think Rust is generally common across, as against C# or C++, which are both low-level language. And I think I just checked the documentation and I saw that Rust is actually way people come, like everyone is saying is actually better, and learn it as a more advanced programmer.
Yeah.
It looks interesting.
Everyone is mentioning Rust. That is why I also mentioned that I want to take a look at it. To be honest, I want to take a look at it because everyone is mentioning it. Right. So yeah, and Golang also seems interesting to me. So I want to take a look at Golang. Yeah. So yeah. So it's really nice. It's really nice. You don't have any other question, right?
No other questions for me.
Okay.
Let's like more to do more research and see how to implement. I think EVMs are still the thing for now.
Yeah.
So
no, not for now. No, I'm an Maxi. I'm an Ethereum Maxi. Don't say it for now. EVM looks like it's going to be the thing for in like 100 years to come. Sure, you get. That's what it looks like. That's what it looks like to me. But what I'm saying is, I want to look at other programming languages at least just to have an advantage and to know how things work in the low level and stuff like that. Well, to me, EVM looks like what is going to be around for 100 years, and that means Solidity is going to be around for a long time. Although other programming languages might come out that have better security features than Solidity and all. But yeah, EVM looks like something that's going to stay for a long time. Because if you say the EVM is going, you're trying to say Ethereum is going. And Ethereum doesn't look like it's going anywhere. It's going from grace to grace, or strength to strength.
Yes. But now, another kind of question is how all these blockchains now, Nigerian context, how do you think we can apply them at least to solve some problems that we think we might face? Because I think right now everybody's just using them for finance, but like I think maybe better use cases.
Yeah, definitely there are a lot of use cases, but it's mostly finance because we we one thing is we feel or we know that the internet was not built to have a system of transfer of value. So the internet was not built for that. So what has been happening ever since the dawn of the internet? That is ever since e-commerce came into the internet. That is since like I think early 2000s up to late 2010s was that we're using traditional payment system like credit cards, right? Credit cards were like that was what we were mostly using. So we found out that we know that those systems are old systems that were not built primarily for the internet, and we have now found out that okay, blockchains are built for the internet and they have a system of value embedded in them, which is cryptocurrency, that is crypto assets. So it's just like you will just tilt more towards building financial applications than thinking of other places that it can be applied. But yes, of course, there are a million places that it can be applied, right? But that I'm just giving you a reason why why it's mostly financial applications that it's geared towards. So yeah, so that's mostly it. But yeah, in terms of Nigeria, I think it depends on the problem you actually want to solve, right? If we have to pick a particular problem that we want to solve before we start thinking of okay, before we start thinking of okay, this problem is not actually financial, blockchain actually solves it for us. So there's nothing off the top of my head now I'm thinking about that can really help Nigeria. There's nothing off the top of my head, but yeah, that's mostly it. But because let me be specific. There's nothing off the top of my head that is non-financial that I can think about that can help Nigeria. Although most people actually talk about voting, right? Voting as a whole.
Yes.
But which can help us. What did you say?
I think there's actually a place I think it can be adopted, like in voting, since everybody can become a node or like a verifier and all those stuff. You can assign that people.
Yes, we can actually do voting. We can do voting, but
like using this consensus algorithm and stuff like that.
Yeah, definitely. It's quite easy to do. I think voting is one of the easiest things to do, because if it's in terms of the only thing is that most of the blockchains are public. Although I don't see anything wrong in the data being public. I don't think if you can do it as simple as this. Okay, we all have NIN, or most people have bank accounts, right? What can happen is the government can say, okay, each bank account is assigned to a particular address, right? And with technologies like account abstraction, we don't have to assign a bank account to an address. What we can do is that you will say, okay, so you don't have to assign your NIN to an address or your BVN to an address. We can just say, okay, you use your BVN details or your NIN details directly to vote. You don't have to have an account on Ethereum at all. The government can just subsidize everything and sponsor all the transactions and say that you are going to use it to vote. So what can happen is each person will come together, right? Each person will come together and will say that, okay, since you have a BVN, you can use your BVN to vote. And once you use your BVN to vote, everything is collated together. Everything can be collated together, and we can build up a system of verification to show that, okay, let's say Olumide voted for candidate A, and another person voted for candidate B. We can verify that it was actually Olumide that voted for candidate A, and INEC did not introduce whatever to make it seem like Olumide voted for another person entirely, that kind of thing. So with the blockchain, we will do all those kind of verification, with things like Merkle proofs. We can be able to show that only the persons that have BVNs can actually vote. So things like that, and I don't see it as a bad thing if the data is public. We can use things like ZK proof to actually hide. We can use things like ZK proof to hide who actually the people that actually voted for candidate A, or we can prove that so number of people actually voted for candidate A. You get what I'm saying? We prove that so number of people voted for candidate A, but we hide who they are exactly using things like ZK proof. So yeah, we can actually apply. I feel voting is a low hanging fruit. We can apply it, but you know the way we are now. Not the way we are. We know the way our leaders are, and the way the current ecosystem is. So yeah,
I get.
So that's basically it. Yeah, that's basically it. I think we're done. Or does Blessing have any questions? Is Blessing on the call? Hello, Blessing.
I'm still here, my boss.
You have any questions?
I think no. I'm good actually. It's just like you said, everyone should pick what they want to focus on and build. But then, as developers, you have to position yourself, whether that developer or core engineer. I would like to. This is overwhelming. Thinking about it, it's just like, you know how Solidity just feels like everyone is into Solidity, and then a company that don't just want any basic developer again.
Yeah.
So you have to now look at what can make you stand out or different in the market, and that's your skills. Now looking at other skills to join. It's a lot of time, but nevertheless, I don't know if it's not safer to just go and focus on learning one whole protocol. Like example, let's just say iOS developer. An iOS developer can just change company, but they always be building iOS apps, and all they have to do is keep going in that field to their senior level.
Yeah.
But you can't just be like, oh, you have to know different things. iOS is just the same language, just learning better ways.
So, yeah. With blockchain is fast. Like I think I was talking to Olumide that I've not had time to sit down and read a lot of stuff because everything is just moving so fast. This was the first time I found time to look at other ecosystems outside of Ethereum, and I'm not even done with looking at ecosystems inside Ethereum and other kind of stuff. So apart from just learning how to code and all, and the reason why it's different from traditional Web2 guys is that they just need to know their code and be good at it. But with Ethereum and all, you have to know the latest innovations, how they applied, how they were able to innovate in building out their protocols, or you just have to know the latest things that are happening in the space so you can have an edge over other persons. And sometimes you need to know the latest kind of cool tech in Ethereum. Like for instance, Foundry is like, it's something that just came in and just took everybody by surprise.
You can't know Solidity, you have to know Foundry also.
Things like that. And there might also be something else that will come out and beat Foundry, and everybody will start looking at it. So yeah, so things like that. So it's a fast ecosystem. Yeah.
Okay, that's all, sure.
Okay, so I think we're done. Let me end the recording. So thanks for coming. If you are watching us on YouTube, you can send us an email and you can follow us on Twitter at Blockchain. So thanks for listening.
Don't forget to like and subscribe to our YouTube channel. Thank you.
Yeah, thank you. Yeah, that's true. So thank you.
You.
Yeah.